will need. Good. All right. So we are now recording this. So I'm coming back to Lambda. Just like we used EC2 in our week 1 bootcamp, where we deployed static website on EC2 instances. It was a simple project. We used a LAMP stack. If you know what is LAMP stack, that would also be a great advantage. But LAMP stack is basically L means Linux, A means Apache, M means MySQL, and P means PHP, which means an application which is written in PHP talking to MySQL deployed on Apache, which is running on a Linux instance. So we started building a LAMP stack, and our intent was to bring Linux server, Apache module. We have not used PHP yet because we didn't need it at that point. We used HTML. We deployed HTML on Apache. So the EC2 was basically a server which we deployed, which was then running continuously. It was like EC2 instance is like a computer given to you till you terminate it. And it is a predefined compute. It's a predefined compute mechanism. I'm also going to share my week 3 agenda on this on this meeting, so that we are looking at something what we are doing. So basically EC2 was a mechanism which gave us a compute instance for our usage for whole month. But in modern world, a lot of workloads or a lot of applications basically don't require a full machine for all the times, because it is not running all the times. It always comes into the picture when someone basically invokes that static website, right? So basically, instead of having compute for forever, generally companies or enterprises use serverless options where things are spun up and then they go away as their work is done. And one of the serverless function which provides a compute on demand or on triggers is called Lambda Functions. So basically, when you write some code in Lambda function, imagine if it is Python code, basically AWS will spin up compute automatically without you have to do that. And as soon as Lambda function finishes its functionality, that compute goes away. So Lambda is basically, I'm going to admit some people. So Lambda is basically a serverless compute alternative, which can save a lot of cost for companies because you don't need an EC2 instance or any other kind of instance forever. And Lambda functions are very flexible. You can write Python code in it. I'll show you today how to write Lambda functions. You can write Python code, you can write Node.js code. So in this session, week 3, we are going to actually build a project which will be something like this. If you see here, I have 5 components in this diagram. On the right hand most side, there is something called DynamoDB. DynamoDB is a database, but it is not a SQL database. It's not like Oracle or SQL. Oracle, MySQL are basically relational databases where um, you have things in tables and tables are related to each other. And it is a very deterministic, structured way of storing data. And you might already know about relational databases in your computer science. Um, Maybe you have databases as a subject, but most of the times we understand relational databases, which are um, basically SQL kind of databases um, with tables and different kind of relationships between those tables. And those relationships are defined by the keys. DynamoDB is not a relational database. DynamoDB is more like a NoSQL database, which can store information in JSON format. So, but it has tables. Internally, it says its storage units as tables. So here we are going to be using DynamoDB, and we will have a table. That table will have 3 um, rows, sorry, 3 columns. If you see my screen, the table shows under DynamoDB, it is having an item, a price, and quantity. So basically, we are going to store items like products. For example, item, what can be an item? Item can be a, water bottle. Um, and what's the price of that item? Say $1. And quantity, say whatever quantity. So this DB will be used to store different kind of items. And that data is will be stored in a JSON format, because that's how today's modern APIs are architected. Lots of JSON, lots of REST APIs to backend REST APIs to fulfill your business. So what we are doing here is we are building backend APIs, and these APIs can basically they are going to be a CRUD operation. If you are aware about um, APIs, REST APIs, the CRUD operations, basically, basic operations are get, put, post, delete. So you basically create more objects or more items by calling put. And you get those items by calling get. And then there is a delete, which will delete the items in the database or in the backend. So basically, we are having a DynamoDB, which will have a table, and we will write 4 APIs, which will be hosted on API Gateway. API Gateway is basically a device or another resource or service which is only used to host APIs. And it abstracts a lot of functionality from backend application. When I say abstract, it means that API gateway can um, do the SSL offloading, authentication, authorization, rate limiting, protecting denial of service attacks. A lot of things which can be common and not included in business logic. So that's the function of API gateway. And in the middle, I have Lambda function. Lambda function is our compute here. Lambda function will have a code which will basically connect with DynamoDB and do the backend database operations. For example, if in the browser, a user says, I need item number 34. Give me everything about it. Give me the details about item number 34. So basically, browser will say URL slash items. And that, one second. So when user says slash items, API gateway, the request will come to API gateway, and the request will be get items. API gateway will invoke Lambda function. In Lambda function, we will write the code which will handle the get request, and then it will talk to DynamoDB and it will get that particular item which was asked in get request. I'll show you that. So that's the whole end-to-end functionality which we are going to be building. These backend APIs are basically going to add dynamism, right? Because here the data which is stored in DynamoDB is actually getting fetched or getting updated. Are you guys following me? Any questions? If you have anything to ask or feel to have clarification, just put it on the chat, because this is what you're going to be building this week. So now we know what we are dealing with. We are going to have a API gateway. On API gateway, we will host 4 endpoints. Those endpoints will be talking to Lambda function, and Lambda function will be talking to DynamoDB. That's our project today. So in this project, the project is CRUD APIs for retrieving and updating items in DynamoDB. First, we will create a table in DynamoDB. Then we will write a Lambda function as a backend. Then we will configure API endpoints on API gateway, which will be get items, put items, get specific item ID, and then delete an item. Then number 4, we will do configure API endpoints with Lambda code. Finally, we will use curl and a browser to test out our functionality. All right. So let's go into our AWS console, because we are going to be doing things in AWS management console. Now sign into my console. That's my console. So first thing we will do is we'll go to dynamodb. That's the dashboard of dynamodb. And in that dynamodb, we will do create table. We'll say we need a table which we need to create. So name of the table, it's called crud-table. Partition key is the ID. We are going to fetch items by the ID. The rest all is all. Let's leave everything as default. You can do many things like encryption, key management, data protection, add a tag. But for now, let's just play around and create a table in DynamoDB. So it is creating a table. Done. So it is active, though it says creating the CRUD table. It will be available for use shortly, which is, oh, okay. So our CRUD table was created. That's our table. Explore table items. Specific. Okay. That's the table. Now what we will do, let's create a Lambda function. I am just going to copy this code because I already got this code, but I'm going to explain it to you. So I'm creating another function. So Lambda is a function, as I already told. Lambda is a function whose main job is to bring compute, serverless compute. So we are not now, see, in traditional ways, when you need to deploy an API, which is going to talk to databases, you will write APIs in Python or in Java. You will have to deploy that code somewhere, right? You would either need a server, and then you will install runtimes on it so that your Java can run, which means JRE. If you have Spring framework, you will install that. You will build that server and then deploy those APIs in WAR or jar files. But here, all of that is taken care by AWS serverless functionality, which means I will only create a function and just write my code. I don't have to worry about runtimes and the servers, and I don't have to run a server forever. Now let's see how it happens. So what is the function name? Let's say my function name is crud lambda. And I'm going to see it is asking what is the runtime. So I'm going to choose the Python. I'm going to have, let's say, Python 3.9. And I'll run that on x86 64. So that's what I will do. And I'll say create function. So AWS has created this function for me. Just note there is something called add trigger. So basically, we will integrate Lambda and API gateway, so that API gateway can use this Lambda function on a specific API calls. But before going there, let's let's create the code. So basically, this code is a Python code. But if you notice, it has Boto3 library. Boto3 library is basically AWS AWS CDK library, which you can use in your Python code to execute underlying API calls. What we are doing here is we are talking to DynamoDB through Lambda, right? So what we are doing is we are telling Lambda that create a client for DynamoDB so that we are provided with APIs which DynamoDB can consume. And then we are saying in that DynamoDB, our table is crud-table. Go to crud-table to get the data. So we have crud-table. I'm going to copy this whole code and give it to you, because when you're going to build it, you can use this code and understand it. Then basically what is happening here is, if you see, there is the code is basically divided into different API calls. If you see delete, then items/id. And then there is a get. Again, when get items ID, then what this code does, it goes to DynamoDB.Table, it gets the item. And then it basically, creates the response body with the item coming back from the database. So basically it has 4 API endpoints code. So in this Lambda function, we will be creating those 4 API endpoints, which will talk to DynamoDB and fulfill your backend API requests. Let me take you back to this place. So we were developing this dynamic backend APIs, which are hosted on API Gateway, talking to Lambda function, which is talking to DynamoDB. That's what we are creating here. Okay. So for every Lambda function, as I already told you, there is something called trigger, and then you have to deploy this Lambda function so that AWS can know um, how to call this Lambda function. Okay. I'm coming back to this. Just to give me 1 second. Are you guys there following me? All right. So coming back to this Lambda function has all the routes which I configured, and those routes are talking to the backend APIs in the database. So once you do that Lambda, we will deploy this function. So once you deploy, now it is ready to be consumed. So once that happens, then we will go to our API gateway. Here, we will create API. We are building HTTP API. So we will create HTTP API. And the API name is going to be, let's say, CRUD. CRUD Dynamo APIs. All right. Let's just create those APIs. And when it comes to configure stages, so stages are basically independently configurable environments that your APIs can be deployed to. You must deploy to a stage for API configuration changes to take place. Unless that stage is configured to auto deploy. So basically what we are doing, as you know, everything which is a compute instance has to be deployed somewhere, right? So we are telling AWS that just deploy to a default stage at this point of time. And in that default stage, we are also saying that make it auto deploy configurable all the times. So basically, we are saying just auto deploy my APIs all the times to the staging environment. And that staging environment will be managed by AWS, and you don't have to worry about it. So that is what we are doing here. We are deploying our APIs in default stage, and we are also saying auto deploy. What is auto deploy? It means when I change my API routes or API backends, the deployment is automatic. Um, so here I'm going to say create. Once that is created, now an API is created and its deployment stage is defined. But now we need to configure routes. Imagine what we are doing here. We are creating routes for get, put, delete on items, right? So we need to create different routes which APIs can take traffic on and talk to backend APIs and respond. So I'm going to say create. First, I'm going to say get, and then say slash items. That's what we're doing. And let's say we are saying get items, which means give me all the items available in DynamoDB table. I'm going to say create. So that is our first path. Let's say we are creating second path, which will be put. And I'm going to say items. This means I'm going to pass the item and say put. And API gateway will take that call and give it back to Lambda, and Lambda will talk to DynamoDB and it will create an item in DynamoDB. I'll show you how to do that. But right now we are configuring routes. Let's create a couple more routes. And these will be, let's say I want to get only a specific item and not all the items. So I'm going to say items ID. And then going to do one more, which is like delete items slash ID. So that's how you get your 4 different routes. Now, our next job, see, we now have the routes. We know how to consume this route. I'll show you how. But what happens if you have these routes? These routes have no code in it. Like they don't have any backend connected to it yet. It is just front end. So for example, if you are building a 3-tier application and you built a front end in Node.js, and on the back end you have Java APIs or Python APIs, and then those APIs are connected to a database. Here we are building our front end in API gateway, but this API gateway needs to be connected with Lambda to plug in the code which is talking to database. So now we are going to do integration with Lambda. So let's say I am working on get items. I'm going to say, create me an integration. It will ask, what is your integration target? I'm going to say it is a Lambda function. So it's going to ask, what is your Lambda function? And I already created a Lambda function, which is CRUD Lambda. And then that's probably is enough. So Grant API gateway. At the end, you will see what is happening here. Grant API gateway permissions to invoke your Lambda function. So basically, you always need permissions, IAM permissions, which can be covered in my last week's session. But at this point, just understand that we are already granting API gateway to invoke Lambda function, because that's what is going to happen. API gateway will invoke Lambda functions. Create. So our first endpoint is integrated with backend. So routes for CRUD dynamic API. These 4 routes we configured one route with our integration. Now let's do the same thing with other. But now we already created an integration, so we can choose that thing here and keep attaching, attaching. So we have now all the routes talking to Lambda. And have you wondered that why not we wrote 4 Lambda functions? We could have, but we don't need to, because we wrote one Lambda function, and in one Lambda function, we configured all 4 routes. The code was catering to all the routes, which I can show you now again, because that might make more sense. Let's go to Lambda again. See this now. So if event routeKey delete, then this will happen. If get, then this will happen. If get items, then this will happen. If put items, then this will happen. So there are 4 routes this Lambda function is handling. So now we have an API gateway, which has routes configured. We have a Lambda function, which has all the code. We have a dynamodb.Table, which has the table. Now probably it's time to test. But how will you test it? Let's go back to our API gateway, because we need a URL, right? Otherwise, how will I access my API? Let's try to find what is my URL here. APIs, if I go here, I don't know where is my URL, but let's, what is that? Okay, this is integrations. I just need my URL. This is ARN. Okay. I hope that is my URL. So as you know, I deployed in a default staging environment. So I went to stage, and there I found this URL. Let's go here. This is our URL, and I would say I'm just gonna try items and get. Okay, I got internal server error, which means somehow get is called and then internal server error came. I don't know what is that, but probably let's now go and put this object. I have, okay, so I told you we'll use curl. I hope you're seeing my screen, and I'm using a terminal on Mac. My intent now is to show you this. I'm gonna clear this and I'm gonna write this command. So basically what it is doing is it's saying curl minus X, put. Curl is basically a, if you are not aware about curl, curl is also important utility available to you on Linux machines, Mac machines. You can mimic HTTP calls. So basically what I'm doing here is curl minus X put minus H content type is equal to JSON. So I'm saying that please call the put API for me. And my content type is JSON, and my body is this. My body is this. In that, ID is 123, price is 12345, name is my item. I'm going to say that, but now I'm going to give the URL where this curl will hit, and I'm going to say on this URL do this. Let's see what happens. No, don't do that. Why are you doing that? Okay, so let me see why it is not putting the element for us. URL is right. Let me go to the Lambda function once again. Oh, I did this mistake. Not write this thing whole. Let's say I'm deploying it again. crud-table. I hope this is fine now. Let's run this command. No, maybe it's not deployed yet. Successfully updated the function crud lambda. One second. Yeah, its name is crud-table. I'm gonna detach once. And then add once more. Okay, so I am hoping they can auto deploy themselves. Let us try again. What the hell? Let's go to CloudWatch. I'll teach you another service. It's called CloudWatch. CloudWatch is where you can see all the logs, which can come to you. So basically, see, these are my Lambda functions where my logs are coming. I'm going to go and see if I can find something in the logs. Code items, unhandled exception. So I got, oh, okay. Oh, okay. I got error. A client error occurred when calling the put item operation. CRUD Lambda is not authorized to, okay. CRUD Lambda is not able to authorized to perform dynamodb put on a resource because no identity-based policy allows the put action. Okay, so basically the problem is, so here you learn how to debug AWS. So I got an error. It says internal error. Then I went to CloudWatch. I found the access denied exception in the logs, and it is saying to me that CRUD Lambda, which we wrote, does not have permissions to perform writes on DynamoDB. So that's fine. We accept this problem. We will now go back to our Lambda and fix if we can give permissions to this function. Okay, let's go to configuration, and there is something called permissions. Now there is something called role name. So I'm going to say edit. Okay, so instead of using an existing role, I'm going to say create a new role from AWS policy templates. Enter a name for your new role. It can be, let's say, CRUD dynamodb role. And I'm going to say, it's asking me for policy templates. So let's say there is something called simple microservice permissions, which is the DynamoDB. So I'm going to say that I want to create a new role for this Lambda function. And this role will have permissions to talk to DynamoDB and do the operations. So once that is done, I'm going to say save it. All right, so that is done. Now let's try again. I'm going to go back to curl and do the same thing again. Okay, now this time it worked. It says put item 123. It is done. So now let's go back to browser and say, give me all the items in the DB. So we got the item which we put in the DB. Let's put one more item in the DB. And this time we will say our ID is 1234. Oops. I'm going to change my item to this is water bottle. Again, water bottle. Good job. Water bottle. And I'm going to say ID from 123 to 456. Okay. and I'm going to execute it. I did curl and I put in the items in the database. I went to browser and I said, give me all the items. And I got 2 items this time, my item and water bottle. So that's how I did put and get. Now let's do one more thing. Let's say I need a particular item, which is items 1, 2, 3. No. I don't know why it is not working, but I think you got the idea. Okay, message not found. I don't know what is not found here. Oh, not found because I have not configured the um, route for this possible API gateway. CRUD Dynamo APIs. No, routes. What is going on? Oh, integrations. Oh, see, I don't have route here. So I'm going to say, give me the same Lambda function, attach, give me the same Lambda function, attach. It is auto deployed, so it should auto deploy. Let's see if I can fetch 1, 2, 3. Awesome. I can fetch an item once I configured the rule for that. And if I say 4, 5, 6, I say 4, 5, 6, I got water bottle. That's good. So now let's try one more thing. And that thing is, I am going to say delete the item from the database, please. And I'm going to do this minus minus X, delete. I'm going to delete this. Let's see if it is deleted or not. I'm going to fetch all the items. Yeah, so 1, 2, 3 ID is deleted. I only get one back, which is water bottle. So that's the idea behind this project. So if we go back here now, see what we have achieved. We achieved DynamoDB. We created a table in the DynamoDB. And then we created a Lambda function. And in that Lambda function, we created the code to talk to DynamoDB. And then we gave permissions to DynamoDB to interact with, permissions to Lambda to interact with DynamoDB. Then we wrote 4 APIs on API gateway: get, put, get, delete. Then we used browser and curl. So that was the dynamic nature of backend APIs, which we created here. And we also debugged CloudWatch logs when we got error in our CloudFormation. So this is what is going to be your work for this week. I want you to create these things in your AWS accounts and configure these 4 APIs and make sure that you can implement those APIs and test it via browser um, and uh, and curl. So that's your homework. I'm gonna write down task, and I'm gonna paste the code which I used in my Lambda function. Your job would be to use the same code, because I am not expecting you to write that code. If you can write that code, that's amazing. But if you don't, it's all right. Because we are exploring Lambda functions. We are not writing Python in this bootcamp. But if you know Python and you can write Python, then you stand apart. Because understand that almost every infrastructure will have lots of Lambda functions, and all those Lambda functions will be probably written Python. So Python is a programming language to go. That's what it is. It was a 3-tier application. It was a serverless application. Okay, good question, sir. How can we apply API keys in API gateway to our API? API keys will be a little. So basically, you can do that. For that, we need to consume APIs. So let's go back a little bit and talk about API keys. So API keys are basically the mechanism to authorize your APIs and authenticate your APIs. And most of the times when you go into outside world, you will be utilizing APIs, which are services provided by other vendors. Maybe your Lambda would be calling a service, a software as a service, and that would be a REST endpoint. So that REST endpoint would require a access key and secret that is called API keys to authorize with that service. So in this our service, we have not used any API which requires authorization, because we just built everything for proof of concept. But when you start building Lambda function who is now talking to a third party API, it needs the AWS API keys. Those API keys would be stored in secrets manager. Very important point. The Lambda function will still remain. So that Lambda function will talk to secrets manager to get the API keys first. And then it will connect to the APIs by providing API keys. API keys are provided in API using authorization headers. So that is the concept, or the JOT tokens. Basically, you will use API keys to get JOT tokens, which are OpenID Connect tokens, from your provider. And then you will be using those JOT tokens to call APIs. So that's the whole point. But the answer to your question is, you will not apply API keys in API gateway. You will apply API keys on Lambda functions. because if you are going to use those APIs which needs authorization, then Lambda function will call them. And those API keys will be stored in a secrets manager for security. I hope that answers your question, but that would be a great project to do. Instead of using DynamoDB, you can call another API which can consume API keys from Lambda, and then store those keys in secrets manager. That is ideally what happens outside in commercial world. Sir, can Cognito help in this case? Cognito can also help, but Cognito is basically a identity broker or a single sign-on provider for consumer identities. So basically what happens is there can be use cases where Cognito comes into the picture, but not in this particular use case. Cognito can be used to procure API tokens and verify them while users are trying to log into a web portal or web application, or Cognito can be used to procure tokens, and those tokens then can be used to call APIs. Yes, in certain use cases, Cognito can come into picture, but that would be a full-fledged use case where Cognito is used as a single sign-on mechanism. But ideally, not everywhere. People can customize API calls by using the API secrets coming directly from the service provider. But Cognito can have its own use case, its own small little project where you can learn everything about identity, single sign-ons, authorization, short-lived tokens, and do many other use cases. Okay. Any more questions? If anyone has doubts, please ask. Because I'm going to ask you to build this now for your project, and then we will integrate our. See, in last 2 weeks we did static hosting on EC2. Then we did CloudFront with S3. Now we are building backend APIs. So we will make something that can stitch all of these things together, right? We have backend APIs, we have static web page. We can make a web application which can serve dynamic pages. That's the whole point of teaching this or bringing these 3 services, so that you can build a dynamic full stack website, or which can have facilities to manipulate and access data. Thank you. That's awesome. Awesome. Yeah, I mean, if once we are done with this bootcamp, there can be like deep dive sessions into Cognito, identity. Like we are just scratching the surface. Like when we go into permissions and IAMs, it becomes the juice is in there, right? You need to secure all of these things, make it debuggable, make it accessible. So you need to know deeply about how IAM works, how the services there works, how the key management works. But it's like step by step. You understand this and then move on to another one. All right. Any more questions on this particular project? If not, I am putting up tasks in the chat window, and then I will follow up with pasting the code. Let me do it here itself, and then I'll put the recording on YouTube so that you can follow it. So number one task is dynamodb table. Number second task is Lambda to handle backend code. Number three, Lambda permissions to access Dynamo. Yeah, sure. One more question. Where is it advisable to use API gateway for accessing resources like S3, DynamoDB, and many more versus using SDK? These are totally two different things. So you can use SDK for accessing, automating, or building the code. SDK has no relationship with the APIs. SDK works on the infrastructure. It understand two things. The APIs are not, API is a very common word. Amazon APIs does not mean the APIs in the applications. So you can alter or you can manipulate your database using APIs, AWS APIs for any API resource, EC2, DB, S3, Lambda. There are APIs. But then there are also APIs which will be your application, like get items. This API is not AWS API. It is an API which is deployed on AWS resource, which can also be accessed by API. So API is a very common word, but you need to understand the difference. So here, we are not using API gateway to access resources like S3 or DynamoDB. We are not doing that. We are using API gateway to reach to our own custom endpoints, right? Here, I have my endpoints, and those endpoints are /items. They are not AWS endpoints. They are the endpoints which will be working on my database, which I spun in AWS, right? So API gateway is used when you are exposing APIs to the world, not AWS APIs, but the APIs to your own application. So that's the difference. And when you talk about, I'm having a requirement to upload some PDFs in S3. So should I make an API or use an SDK from security point of view? So no, you should just, it depends. Like if you want to upload some PDFs to S3, you can use AWS SDK. You don't need APIs. AWS SDK is more secure in doing that. But if you want someone else to upload PDF files on your S3 bucket, then you need to now think about whether you can make your own APIs, right? So that's the difference. Is the upload coming from your consumers or it is coming from you? If it is only you, then you use SDK, secure. But if you need to extend the upload functionality to the whole world, then you need to create APIs which will be front-ended by API gateway. And then that API gateway will talk to Lambda, and the Lambda will upload your files to S3. So once number 3 task is done, where Lambda permissions to access DynamoDB, then you create API routes on API gateway to do these 4 things. slash get slash items, put slash items, get slash items, ID, delete slash items, ID. All right. So that's what you do. Okay. That once the routes are established, then you integrate all these routes with Lambda backend. Then you will use curl to put items in DB. After that, you will use browser to get, and then finally use CloudWatch to examine the logs and find the events to confirm that you can understand how CloudWatch works. So these are like 8 tasks which I put it on the chat. Please make a note of all of them and do it. And I'm gonna go to Lambda. And I want you to take this code. Just and just make sure that okay, I can't paste here, but I'll paste it on somewhere else. Okay, I can probably do it by chunks. Can we use API Gateway and AWS Lambda for web or mobile backends, like integrate it in code, or can it just handle CRUD operations? No, CRUD operations are just I shown you a way. You can totally use API Gateway and AWS Lambda for web or mobile backends. You can write whole backends in Lambda and routes in API Gateway. And you can not only just do it with HTML, but do it with REST. Also, how fast would be the data be returned to the user? The fastness will all depend on how scalable your infrastructure and how quick it is. It all depends on how your database scales. If in case of DynamoDB, which handles scales on its own, I think it is like lightning fast to get the data back from database to the user. Like you will not even see any latency. Probably latency is very less. But if you ran in some kind of your application issues, you can face delays, but it's all pretty streamlined and seamless. Awesome. Any more questions? That's awesome. Maybe next time you can bring me all the questions. So I pasted all the code, all the Lambda code in the chat. I'll also put it somewhere on my YouTube description, which the video recording, so that you can use it. This is, if you forget about CRUD operation, this is basically, we already wrote a backend for mobile or web application. It's just a demonstration. Like you have get, you have put, you have delete, you can do any operation, and you have database available. So it is not just a CRUD operation, but it is a very generic way of defining a backend, and any backend can be built using this kind of functionality. How to simplify the scaling process in AWS Lambda? Are there specific steps? So you don't have to do much on scaling Lambdas, because remember, the Lambdas are serverless feature of compute. So the scaling of Lambdas, I need to check if there are any quotas. But apart from that, the scaling of Lambdas are taken care by AWS internally. That's the whole point of using serverless. But that's a good question. The scaling happens on your front end or on your on your or on your database on your database layer. That's the beauty of serverless. But in case of auto scaling, in case of EC2s, you can always use auto scaling. Amazon EFS. What is EFS? Amazon File Server? No. No, I don't think they have any relation. EFS is basically Amazon Elastic File System. Um, um, but when you talk about ECS, or ECS is basically container, right? That is a different ball game. That is also serverless, but containers are containers run in their own environments. Um, and they scale based on their own configurations. Like if you're using Kubernetes or ECS, they will have their clusters and ways to scale down or scale up. Yeah, there is something called quota increase. Um, there is something called okay, I'm going to send you a link which talks about the scaling in Lambdas, and it is it is more about the quotas and concurrency limits. Um, if you are utilizing the same Lambda function for a, a in a very frequent manner, then you need to get the quotas from service teams enabled to handle that kind of load. But this document talks about that. But I still don't think that ECS has anything to do with, or EFS has anything to do with Lambda scaling. Oh, okay. Okay. Here is the link. I was not pasting that link in the chat. Okay, I sent messages to Ayush instead of the chat, which is fine. Awesome. Okay, so any more question, guys? If not, I'll close this and send you all the recording links and details later on today. All right, guys. Last chance. If anyone has to say anything or ask anything, please do go ahead. Uh, Otherwise, we will talk to you next week. Awesome. Thank you all. Yes, go ahead, Harsh. What's your question? How is Fargate different from EC2? Lot of difference between Fargate and EC2. Fargate is basically um, um, Fargate is also serverless. Fargate and Lambda are closer to each other. Um, but Fargate is not related with EC2. EC2 is a form of compute which is not ephemeral. Like you get a server and then you run a server and you manage a server. But in case of Fargate, Fargate can spin up containers for you in ECS or EKS. So Fargate is more serverless than, and EC2 is more server oriented. EC2 is a server. Fargate is a serverless. That's the difference. But Fargate is more closer to lambdas and containers. Great. Okay. Awesome. I will take 30 more seconds if any more things coming up. Okay, everyone. I'm gonna close this call. Gonna go to sleep. You guys wait for my session recordings and then complete all the tasks. Bye bye.